Alright, this is lesson number 89B in Algebra 2, and we're in the second part. We're talking about products of chords and secants. So I've got a bunch of circles down there that we're going to pull up here and use. Now, if you remember, it was a while back, we did some things as far as some chords inside circles here. And one of the things that we did was, if we have a chord like that and a chord like that, and we want to know what this angle right here is, and we know that this is 80 degrees and this is 90 degrees, that x then would equal the 80 plus the 90 divided by 2, and therefore x is 85 degrees. Okay, that was quite a ways back. Seems like it was around Thanksgiving-ish. But anyway, if we want to know any of the angles here, we just take the degree of the arc, the degree of the other arc that these two chords cause, and add them together, divide by 2 since there's two of them, and that'll give us this angle here, which means we've got this angle, which means we have this angle and this angle because of supplementary angles. So we can find all four of those based on just having that arc and that arc. We also did, see if I can get rid of what I wrote in blue. Yep. We also did something like this. And if you wanted to find this angle right there, you took this being 90, this part here, and this part out here being 170, and you did 170 minus 90 over 2. So when the angle you're looking for is outside, you take the difference between the two arcs that it has included, and take the difference and then divide by 2. Okay? So, when a chord intersects in the circle, we're going to try one just like that. I'm sorry, I'm seeing an awful lot tonight. It's late and I just don't seem to be thinking straight. Okay, so in this lesson we're going to do something else. We're going to draw two chords. And we did this before, and that was where I wanted to find this angle, so I took this and added to this and divided it by 2, and I was able to get that angle right there. Now what I'm doing is I'm trying to find lengths of chords. So let's say that that's 2, this is 6, that's 3, and that's 4. Okay, one of the things that's really cool here, if you're a math geek, is if you multiply those will equal the multiplication of those. Okay, the products of the chord segments are equal. So that's kind of a cool thing, because sometimes you're not given all of the information. Welcome to algebra, right? Sometimes they give you a chord here and a chord here, and they say 3, 7, 5, x. Well, the product of one chord, 5x, equals the product of the other chord, 21. So x equals 21 over 5. So that's the length of that chord right there. Okay, so just to remind you the difference between a secant and a chord. A secant is like that. A chord is just this part within the circle. It's the part of the secant that is within the circle. Okay, so when I'm talking about secants and chords, that's what I'm talking about. The secant is the entire line. The chord is just the part that is inside the circle. So hopefully that'll clear any question up you might have there. Okay, so let's say that we have a line segment that goes through here, or a secant, and another one that does this, and this is 10, and this is 2, and this is 3, and this is 5. Okay, so what's equal here? What is equal here is the outside segment. Let me write that again. The outside or external segment times the sum of the segment, 8, equals the external times the sum. So I took 3 plus 5, multiplied it by 3. 2 times 10, multiplied it by 2. 2 plus 10, multiplied it by 2. So 24 equals 24. Okay, so it's good to have these down in your notes because you're going to have to do these not only in here, but on the SAT you'll run into them as well. Okay, let's look at another one here. Let's do that and that. And this is 5, and that's 3, and that's 4, and that's x. So 4 times 4 plus x equals 3. 3 times 3 plus 5. So we get 16 plus 4x equals 24. 8 times 3. 4x equals 24 minus, so that's 8. So x equals 2. So that is going to be how long that is. So let's see if that's right. 6 times 4 is 24. 3 times 8 is 24. Yep, that works. Okay, notice what we've got here. We've got this secant, and then we have this one here, and it is tangent to the circle and then stops. Tangent means that the line crosses, intersects the circle at one point. Alright, the way this works is we do this one the same way as we did in the last one, 4 times 4 plus x. But when we have, oops, where did I get an 8? 4 plus x. But when I only have one line here, or one number there, I just square it. So 16 plus 4x equals 64. 4x equals 54, 48. So x equals 12 for right there. Okay, so the rest of the lesson is proving that all of this is true, and I'm not going to worry about proving all that's true, so that's it for lesson number 89.